Okay, getting down to the end of the reviews. Okay, so these exponents, 6 to the third, that means you just take 6 times 6 times 6. Whoops. That's 216, so that's your product right there, 216. Get negative 5 to the fourth, that means negative 5 multiplied by negative 5 multiplied by negative 5 multiplied by a fourth negative 5. Okay. Now the product's going to be positive because we have an even number of negative factors. So I can expect this to come out positive. So 625. Okay, negative 5 to the third. Okay, now this is an odd number of negative factors, so the product's probably going to come out negative. Okay, negative 125. Okay, now if we have a fraction to a power, we just list the fraction 3 different times. And then we multiply and find the product, okay? So 3 times 3 times 3, it's going to be 27. 8 times 8 times 8 is going to be 512. Okay, enough of that. Now, simplify completely. Okay, now I have to simplify all of these expressions, get from here to here. Okay, now the first thing I want to do is make sure I have a dividing line and then circle where we have parentheses. So that'd be right here, and there's a 2 outside that. Remember, this is not in parentheses, so we don't have to multiply that 3 right here where my finger's at. Okay, so the bases are 5 and M. So 5, number 5, letter M. So the 5 is to the 1 power. But since we're in our circle, where everything's to the raised to the second power, we got to take 1 times 2, and that's 2. Okay, now the M factor. We have 6, but that's in the bubble, so 6 times 2 is 12. And then here's my other M, and it's on top of the line, so I would use the addition operation. And then I don't multiply 3, I just write 3 down because that's not in a bubble. It wasn't in a parentheses. So 12 plus 3 is 15. Okay, so here are my factors, 5 to the third and M to the 15th. Now they're both positive, so they're both going to stay. So stay and stay. Okay, so 5 to the second, it's on top, it stays on top, and likewise with the M, it's on top, stays on top. All right, now here's my 2 factors. I'm done. They're going to stay on top of the line, but I can clone the 5. So 5 times 5 is 25. So replace your 5 to the second with 25. Then the M to the 15th is going to stay, because I can't clone the M, much less 15 times. Okay, if the bottom's empty, that's okay. Okay, I don't need to write anything. Okay, my next problem. Underline where you have the line, so you circle your parentheses and the power outside. So any power coming out of here has to be multiplied by negative 3. So I have a number 5 and a letter X, 5 times X. Okay, so the 5 is to the 1 power, okay? So it's in the parentheses. I need to multiply 1 by negative 3. 1 times negative 3 is negative 3. And the X is also to the 1 power, and we need to multiply that. 1 times negative 3 is negative 3. Okay, so here are my factors. They're both negative at powers. Both factors have negative exponents. So they both need to go to the opposite side of the line. Okay, so this 5's on top, so the opposite of the top is the bottom, and then the 3 turns into a positive. Then the x, the opposite of the top is the bottom, and the negative 3 switches to its opposite, which is positive 3. Okay, now, remember, anytime the top ends up being empty, we need to put a factor there, and the factor is just 1. Okay, so I carry the 1 over. Then let's look at these exponential factors. The 5 can be cloned. That's 5 times 5 times 5. Okay, that's 125. So we replace this with 125. Then the x really is a variable. It can't be, well, you can clone it, but it's a waste of time because you don't know what number it is. So x to the 3rd. Okay, and that's simplified. Remember, if the bottom ends up empty, that's cool. But if the top ends up empty, you need to put a 1 up there. Okay, our next expression. Now, the dividing line, there's 2 different ones. All we need to do is connect it. And then I circle where I have parentheses. I have 2 different parentheses. This one has a 3 outside of it. And this one here has a 4 outside of it. All right, now on top you have the number 2, you have the number 3, you got the letter x. So you got 2 times 3 times x. Now under the line we have the letter x. Well, I already put letter x on top. And then I have letter y, which I have not put on top, so I need to actually write y on the bottom. It doesn't go on the top because you only have one single y factor, and that's on the bottom, so that you're just going to have it on the bottom to start off with. Okay, now everything is in a bubble, so every power from this expression has to be multiplied by the 3 here and by the 4 here. I don't care if it's on bottom. The bottom's part of the parentheses. Okay, so 2's to the 1, but we got to multiply 1 times 3. And that's 3, so it's 2 to the 3rd. Okay. Now 3 is to the 1, but that, again, that's in the bubble. That's the parentheses is surrounding that, so 1 times 4 is 4, so 3 to the 4th. Now when you get to the variables, you see how many of them you have. You have an x here and an x here. So we start with the x from the top. Again, that's in the bubble, so I will need to multiply 4 times 4, okay? 16. So we have a 16th power. And then our other x, where's that at? Is that on top or bottom? Looks like it's on bottom to me, so that will be a minus operation. And again, I know this x is on bottom, but don't just write 2 down because the parentheses surrounds the x as well. So 2 times 3 is 6. Okay. 16 minus 6 is 10. Okay. So x is to the 10th power. Okay, now what's our y? Our y is to the 2nd, but again, that's included in the parentheses. Okay, so I don't want to just write down 2. That's wrong. It's in the parentheses is around it, so the 2 has to be multiplied by 4. 2 times 4 is 8. Okay, now here are my factors. 2 to the 3rd, 3 to the 4th, x to the 10th, y to the 8th. Okay, they're all positive, so they're all going to stay in the same place. So stay, 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 stay. So 2 to the 3rd stays on the top, 3 to the 4th stays where it's at, and x to the 10th stays where it's at, and then my y factor stays where it's at. Okay. So again, you got to look at where the parentheses at. If it also surrounds the bottom, then the bottom exponents are going to need to be multiplied by the outside power, just like the tops are. Okay, so here are my factors: 2 to the 3rd, 3 to the 4th, x to the 10th, y to the 8th. Okay, you can clone the 2. 2 times 2 times 2. Well, 2 times 2 is 4, and then 4 times 2 is 8. Okay. So I replace 2 to the 3rd power with an 8. 3 to the 4th, that'd be 3 times 3 times 3 times 3. Might need a calculator for that probably. That's 81. Okay, so 3 to the 4th now turns into the number 81. And then you write times x to the 10th, and then y to the 8th down here. Now don't just leave 8 and 81. When they end up on the same side of the line together, you need to actually execute the operation. Okay, 8 times 81. 648. So that's a simplified expression. I have 648 times x to the power of 10, and then over y to the 8th. Okay, this next one. Now, your line's drawn. Okay, the dividing line's already there. Now, I have a parentheses, but look at where it surrounds. It only surrounds the 2 and the e, okay, with the negative 4 outside. So I make my bubble just right there. Okay, so on top of your line, we have a number 2, a letter E, and a letter G. Give yourself some space between the E and the G. Then on bottom, I have the letter E. Well, I already have that one on top. And then G, I already have that one on top. Okay, so 2, let's talk about that. Now it's to the 1, but that's in the circle. So we need to be multiplying 1 times negative 4, and that's just negative 4. So the 2 is to the negative 4th power. All right, now on E, there's 2 E's first off, know that. So this E is to the 1, but that's in the circle, so 1 times negative 4 is negative 4. Okay, where's your other E at, top or bottom? It's on bottom, so that indicates division. So I need to subtract the exponents, that's the quotient of powers. And look at your parentheses. Does it surround the E on this E right here? Does it surround that? No, it does not, so I just write 5 down, okay? And then I just find out what negative 4 minus 5 is, and that's negative 9. So E is to the power of negative 9. And again, if you're wondering how that's negative 9, if I'm at negative 4 and I subtract 5, I go this way. So negative 5, negative 6, negative 7, negative 8, negative 9. Okay, that's how that works. Negative integers. Okay, now G. Here's the first G. Remember, it's outside the circle. It's outside the parentheses, so we can just write 5 down. Then my other G, is it on top or bottom? It's on the bottom. So we're going to subtract, but you don't just subtract 3. The 3 is negative. So you put negative 3. And you can use your calculator. I'm going to explain why it is what it is. 5 minus negative 3 is 8. Okay. So G to the 8th power. Now I'm going to explain why that's 8. If you subtract a negative number, okay, really that's plus the positive number, okay? If you're at 5 and you're adding 3, you're just adding 3 to it. 6, 7, 8, G to the 8th, okay? All right, now my factors, there, and there. So this 2 here has a negative power. That will go to the opposite side because that power needs to become positive. This is negative. That goes to the opposite side. And this 8's positive, so that stays. Okay. So 2 says opposite. The opposite of the top's the bottom. And why do we do that? So we can make our power into a positive. So I can clone it. Okay, and then the E goes into the denominator, and that negative 9 becomes a positive 9. And then this stays, it's on top, it stays on top. Okay, so out of those 3 factors, which one can actually be cloned? Well, not the G, that's a variable. 2 can be cloned 4 times. That means multiplying the 2's. Okay, 2, it's going to be 16. Okay, so replace that with 16. And then the e variable stays the same, so e to the 9th. All right, and that's simplified. Okay, that one's a confusing one. You got to pay attention on these two. Where your here the parentheses was around the whole fraction. So this and this need their exponents times out here. Same with this one. This all need their exponents multiplied by 4 down here. See here, there's a parentheses, but it only surrounds this. Okay, so again, just these two get their exponents times. The rest of them don't. The rest of them just I write down. Okay. Remember, if you have to subtract a negative, you do subtract a negative, but okay, now this got cut off. That's a 0 right there. Now you need to write that number in scientific notation. Now, that means you have some number times a 10, and then there's an exponent. That's what scientific notation looks like. Okay, so here's my first decimal. We need going this way. You're always going this way when you find the number you're going to put the decimal after. So that's 0, 0. That won't work. Nope, nope, nope. Right there. Okay, 3. So decimal needs to go between the 3 and the 5. Say for it to move it there, it's got to go this direction. Okay. Now, what direction is that? That's moving to the right, which means my power is going to be negative. Okay. Right insinuates a negative power. So negative. Okay. Now move it. So 1, 2, 3, 4, 5. Okay. So I put my decimal point. There's a 3 in front, and then 5 and a 9 behind it. Now you just count the digits between the first decimal and where you put your other one. So 1, 2, 3, 4, 5. So 3.59 times 10 to the negative 5th power. If you don't trust your answer, you can always check it on your calculator. And that looks exactly like with what I started with. Okay, to take a number from scientific to standard, you just use your calculator. 5.3 times 10 to the 7th power. There's a number. There's no decimal. The decimal's at the end. You can see it right there. So if it's at the end, you can just leave it off of your answer, but then you need to put commas. So 53 million is the actual number. Okay, then the final problem. Only one story problem here. Okay, a recent college graduate accepts a job at a law firm. The job has a salary of $32,000. The law firm guarantees an increase in pay of 3% per year. Find the employee's salary after 5 years. Down here, it got cut off. It's supposed to say dollars equals. Got your answer. Okay, with these two highlighted units, one of them's a dependent, one of them's independent. So dollars and years. So the time, the years is my X, and then the dollars is my Y. So it's per year. You can go put the dollar label on top. Now, the only thing I see about per year is the 3%. Well, that's not the same as having $3, okay? So making that line is not going to be the way to go. Okay, so first off, with a percent, you're going to need an exponent because it happens every year. And the exponent is how many years you have. Well, you have 5 years you're trying to figure out. Okay, then I use my original times percent equals new. Now, since the percent is every year, okay, it's per year, you need a power on your percent factor. Okay, so let's figure out our percent factor. We take 100%, and it's a 3%, so we need to add 3% because it's increased, okay? The word increase insinuates adding. So that's 103%. Remember to divide that by 100. Okay, and I got 1.03. That's your percent factor. Okay, and then the power on that is 5, okay, because it's per year. Now, 32,000 is the original, so that goes in the original factor. and then I put X there for the new. Now, look at the operation times. You can just do your calculator. So you go 32,000 times 1.03, hit your caret button, and then 5. Okay, now this is a money amount, so I want the two digits that come, the first two digits after the decimal. So I get 37096 decimal, and then 77, because it's a dollar amount, so you can have the first two digits. So $37,096.77. Okay. Next problem. Now these are percents, but there's no power because they don't happen per year like that last one did. The original price of an item is $55. It's on sale for 20% off. That insinuates a subtraction. Find the new price of the item. So with these addition, subtraction with percents, we want the original times percent equals new. So original percent new. So we know what to do with the percent. We have to take the 100%, and this is where we subtract 20. Okay, so that's 80%. Then divide by 100. And 80 divided by 100 is 0.8. So my percent factor is 0.8. Now I read the sentence with the $55 just from here to here. It says that's the original, so $55. And then to find the new, we just multiply, but there's no power because it does not say 20% per year, just 20% one time. So 55 times 0.8, 44. So $44. Put the same label you have here. Okay, an item is marked 20% up. Up insinuates addition in price. The new price is $60. Find the original price of the item. Okay, so again, those plus minuses tell you how to set the problem up. Same original, percent, and new. So to do our percent, we take 100%. Now remember, plus means adding 20%. That's 120%. Now that, again, that has to be divided by, anytime any percent in an algebra equation needs to be divided by 100 before it goes into the equation. So 1.2. Now read the sentence with the 60. From here's a period, here's a period. The new price is 60, so $60 is the new, and I'm finding the original. Okay, I can't multiply here because that factor is not known. So I connect the lines, and I divide both sides by 1.2 because that cancels and x is now by itself. Then I just put a 1.2 under the line here, and that means I divide 60 by 1.2. Okay, I got 50. So $50 was the original price. $50, then it's marked up, and it ends up at $60. So that would be a $10 markup. Okay, the original price of an item is $60. The item is marked up 60%. Find the new price of the item. So again, up insinuates plus. Okay, so original percent doesn't happen per year, so I don't have a power. And then new. Okay, so my percent, we have 100%, and then we add 60% to it. 100 plus 60 is 160, and then divide that by 100. Okay, 160 divided by 100 is 1.6. Okay, read the sentence about the 60. It says that's the original price, so $60 is here, and I need to find the new price. And finding the new is easy. You just do the multiplication operation. 60 times 1.6 equals x, so I just find what 60 times 1.6 is. Got 96, okay, $96. Okay, an item's marked 30% off. Off insinuates minus. So with that minus, we know the way we're going to set up this percent problem. Okay, in real life, this is really the basis you need to know for percents, as long as they insinuate plus, minus, whatever. So we have original, we have percent, we have new. Okay, so the percent, we take 100%, and off means we're going to subtract 30%. That takes me to 70%, so I divide that by 100 before I put it into my equation. 0.7. Okay, now from here it says 56, and new price is $56. Okay, that means X is my original amount, so I don't multiply here, I just connect the lines, and I put the 0.7 factor so that it can be canceled out. 0.7 under 56. So when I divide, it has to be 56 divided by 0.7. Now, some of you might be wondering, how come when you divide it ended up bigger? Well, when you divide by a decimal that's less than one whole, which 0.7 is, 0 point anything is less than one whole, the number gets bigger. Okay. So it's $80. Okay, so you had $80 and you took percent off, and now you're down to 56. Okay, then the next page, there are 400 students in a school. 45% attended a homecoming dance. How many students attended the homecoming dance? Now, this one does not have those words that indicates plus or minus. So this is a part whole percent problem. So part whole. You got to know what your part is defined as, and it's underlined. Attended, just put attended dance. Okay, so I have 100%, and then the percent I have is 45. You're like, well, don't you have to divide that by 100? Yeah, I am right here. Although I'm not actually going to do it because the cross multiply and divide will do that for me. Okay, read the sentence about the 400 students from here to here. Does it say they attended a dance? Do you see that verb? No, I don't. So 400 is the whole, and I'm finding the part that attended the dance. So I cross multiply and divide, which everybody should know how to do. That's kind of a middle school thing. So 45 times 400 divided by 100 is 180, okay? So it's 400 students, so 180 students would be the label. Attended that dance, 180. Okay, 20% of the students receive vaccinations. 40 students receive vaccinations. How many students are there? Okay, so again, no word that indicates plus or minus, so I just use my part over whole. Okay, the part are those that received vaccinations. Okay, now I use 100% there and 20% here. Really, because this is okay. Then read the sentence with the 40. Does it say they receive vaccinations? Clearly it does. 40 students receive vaccinations, so 40 is your part, X is your whole. And you cross multiply and divide. You take 100 times 40 divided by 20 is 200. Okay, so it says 40 students, so it's 200 students. 20% of those receive vaccinations, so that would account for 40. Okay, 40% of the students in school earned an A in biology. There are 150 students in school. How many earned that A in biology? Again, no word indicates plus or minus, so I put 100% here. Or no, part whole first. 100% goes there, but I like to. Okay, the part, what they do? They earned an A in biology. Okay, so we have 40%. Now you got to read the sentence. Read from here to here. There are 150 students in school. Well, it doesn't say they earned an A in biology. That's just how many there are whole. Your job's to find the part that earned the A. So I multiply 40 times 150 before dividing by 100, and that gives me 60. So again, it's 150 students, so it's 60 students. 60 students earn the A in biology. Okay, then finally, 25% of the fish in the pond were walleye. There are 100 walleye in the pond. How many fish are in the pond? Okay, so again, nothing indicates plus or minus, so it's a part-whole problem, not the original times percent's new. That's when there's a plus or minus with the percent. Okay, the part is were walleye. Okay, now my percent's 25, and that goes over 100. Okay, now the actual amount. Okay, from here to here. Part, remember, the part is were walleye. Is it same thing about walleye with the 100? Yeah, right after it. So it's 100 walleye is your part, and you're trying to find the whole. Because you can have other types of fish in there with the walleye. It could be bass, lake trout, whatever. Okay? However, you can fill it with different types of fish. Okay, so I cross multiply and divide 100,000, 100 times 100 divided by 25, and I got 400. So there's 400 fish in the pond. Okay, now this wouldn't be 100 walleye. The label's kind of screwy on this. It says 100 walleye, so you're like, oh, 400 walleye. No, it says how many fish, so there'd be 400 fish. Okay, if you can't do the label right, just leave it off. That's fine. I just want to see that your math is correct. All right, guys, that's all I have to say on that today. You have this, and then there's not enough time to do the polynomials. That's the one where you go blank x second plus blank x, but that's everybody gets that by now.